Today we're going to be talking about solving linear systems with matrices. So what we're going to be doing specifically is talking about inverse matrices, and I want to start by showing you how to write a linear system as a matrix equation. So we're going to start by setting this up. We're going to take the coefficients of the terms, so we're going to have 2, -4 in the first row, and -3, and this is really a 1 in front of the y, so 1 in the second row. Then you're going to write down the variable matrix, so x and y, and that is equal to the constant matrix of 7 and 12. Okay, so let's say that we want to write a matrix equation for this one. X plus 9y equals 20, and 2x minus 4y equals 15. You're going to put a 1 in front of your x, and your coefficients are 1 and 9, 2 and -4. Your variables, x and y, and then your constants of 20 and 15. So you've basically got 3 matrices here. Okay, so that is pretty straightforward. Let's move on to solving an actual system. So let's start with this one. We have our coefficients are 1 and 1 in front of the x and y, and 1 in front of the second y. Let's set this up as a system, so system of matrices. So we're going to have with matrix equations. So we're going to have 1, 1, 2, 1, x, y, and 8, 1. All right, now the first thing we need to do is we need to find the inverse of the matrix 1, 1, 2, 1. And so the way we do that is we take 1 over the determinant of matrix A. And if you remember correctly, what we do is we reverse the A and B, say if or A and D, I should say, if we have A, B, C, D as the entries in our matrix, we reverse D and A, and we change the signs on B and C. Okay, so let's go ahead and do that. I'm going to do that in a different color off to the side here. So if we find the determinant of A, remember we do that by taking 1 times 1 minus 2 times 1. So we end up with 1 minus 2, which is -1. So we have 1 over -1 times, we're going to reverse the A and D, and in this case it really doesn't change because they're identical, and we're going to take and change the signs on 1 and 2. So we have -1 and -2. Now this is really like multiplying by -1, so we're going to have -1, +1, +2, -1. And that is our inverse. So what we're going to do is multiply each side of our system of equations by that inverse. Now what is going to happen? Just a minute. I need to write down also the original matrix there. So we have our inverse times the original. So we have 1, 1, 2, 1. There we go. We still have our variable matrix. And now we also need to multiply the other side by that inverse. Okay, now the neat thing that's going to happen whenever you multiply by an inverse matrix, they cancel out. So we're left with just the variable matrix. On the right-hand side, I'm going to extend this page a little bit. We need to multiply, so we're going to take the first row times the only column. So we're going to say negative 1 times 8 plus 1 times 1. So we end up with negative 7 plus 1, which gives you negative 7. So there's our first entry. And then we're going to take the second row times the only column. So we're going to have 2 times 8 is 16. Negative 1 times 1 is minus 15. So that is, I'm sorry, I actually gave the answer there. Sorry about that. So 16 minus 1, negative 1 times 1 is negative 1. So 16 minus 1 is 15. So we have x equals negative 7 and y is 15. Okay, so that is the solution of that first system of equations. So now let's continue. Let's try another one. Now, we were really fortunate with this one. It turned out nice and neat. Sometimes you do get fractions. It's nothing to worry about. Let's set up the second matrix equation. We have our coefficients in front of the x and the y of 1. So we want to write out 1, 1, 5, 2. X and y is here. And then that's equal to the constants of 2 and 14 in our matrices. We need to find the inverse matrix for 1, 1, 5, 2. So we have to start by finding the determinant of A, which we find by saying 1 times 2 minus 5 times 1. So we have 2 minus 5, which is negative 3. And as you know, the formula for finding the inverse matrix, we take 1 over that determinant of negative 3. We switch the 1 and the 2, switch those positions, and change the signs on the other terms. So now we can multiply. And so we're going to get fractions here. We have negative 2/3, positive 1/3, positive 5/3, and negative 1/3. Okay, so we're going to multiply each side now by that inverse matrix. So we're going to have negative 2/3, 5/3, 1/3, negative 1/3 times 1, 1, 5, 2, and then x and y equals, we have negative 2/3, 5/3, 1/3, negative 1/3 times 2 and 14. Now, when we go to actually do the multiplication, we know that the inverse of A cancels out with matrix A, so these two matrices cancel. So we have just x and y left. On the right-hand side, let's actually do out the arithmetic here. First row times only column, so we're going to have negative 2/3 times 2 plus 1/3 times 14. So we have negative 4/3 plus 14/3, which gives us negative 10/3. I'm sorry, positive 10/3. So our first entry is 10/3. Next we have second row times only column, so we have 5/3 times 2 minus 1/3 times 14. So we have 10/3 minus 14/3, which gives us negative 4/3. So our second entry is negative 4/3. So we end up with a solution of the system of x equals 10/3 and y equals -4/3. And if you want to check that, you can just plug that right into the two original equations and they should work out just fine. Well, thank you for joining me, and we will continue with this in class.